In this episode, we are going to look at a math result which, believe it or not, feature in the anime Yuyushiki, a light-hearted comedy featuring three high school girls going about their simple everyday lives. In the episode 6 of the anime, the girls forgot about what day of the week it is and wondered if there's a way to quickly tell which day of the week it is by just knowing the date itself. Curiosity got the best of them, so they searched for a way to do so on the internet. But to their disappointment, and to the delight of the math nerd in me, they stumbled upon Zeller's congruence. Being high school students, they have no idea how this result could help them figuring out which day of the week it is. So let's help them out. I'm not only going to show you how to use this to figure out, let's say, which day is 30th March year 3199, but will also explain to you exactly how the formula works. First of all, I need to set up a bit of language we are going to use later throughout the video, so all of us are on the same page. You might or might not be familiar with the congruence notation, but don't worry if you don't. Although it's a bit of simplification for now, you can think of it as a way to express the remainder when we are dividing a number by another number. As an example, 35 is congruent to 3 modulo 8 because 35 gives a remainder of 3 upon division by 8. The second thing you need to know would be the way our calendar system works. Most countries in the world uses what we call the Gregorian calendar, where each month, with the exception of February, has either 30 or 31 days. The month of February will have 28 days if it's not a leap year, and 29 days if we are in a leap year. How do we determine if a year is a leap year? Well, most of you probably already know that years which are divisible by 4, like 2020 and 2000, are leap years. But something which is rather less well known is an exception to this rule. For the turn of the century, such as year 2000 and 2100, these years will only be a leap year if the year itself happens to be divisible by 400. Therefore, while year 2000 is a leap year, so there are 29 days in February, year 2100 would not be a leap year. If you are wondering why such rule exists, the time taken by Earth to go around the Sun is not exactly 365 days, but a bit closer to 364.25 days, which is why we have a leap year every 4 years. But again, the number is not exactly 364.25, but something lesser than that, only slightly. So if we keep adding 1 day every 4 years, we'll have added too many days over the course of many centuries, and important dates like the solstice and equinox will slowly but surely run out of sync with our calendar days until the difference is noticeable. This causes issues back in the day as people rely on the calendar for their harvest season, so the original Julian calendar was abolished and the new calendar specifying the no leap year rule every century except for every 400 years was used instead. The final thing you have to know before I can show you how the formula works is a floor function, which is not hard to understand. Given any number, the floor function gives you the integer part of the number, and you disregard the decimal part. You can also think of it as the largest integer, which is smaller than the given number. Now that we have all the tools we needed, let's break down the Zeller's congruence. On the left hand side, we have h, and that's our final output. It is an integer from 0 to 6, with 0 standing for Saturday, 1 for Sunday, 2 for Monday, and so on. To explain the right hand side, it is easier for me to show you an example directly. Suppose we take the example 1st January 2020, as suggested by the girls. Q in the formula would be the day of the month, which in our case is 1. M stands for the month in the year, but for reasons we will explain later, January and February are counted as the 13th and 14th months of the year, and so M equals 13 for January. K would stand for the year modulo 100. In our case of 1st January 2020, using our convention, January is actually the 13th month of 2019, so our K here is 19. Finally, we can think of J as a century counter, or more easily, the quotient when we take the year divided by 100. In this case, it will be 20. We can put everything together and use the floor function I introduced earlier to see that h is 4. So 1st January 2020 is a Wednesday. Now that we are more comfortable at using the formula, let me break down to you, as promised, how this formula actually works. You can think of the formula as a mechanism of keeping track of days which has passed, before you finally take modulo 7, as days in a week would cycle once every 7 days. The variable Q would be responsible to record the passage of time in a single month. When we move from 1st Jan to 2nd January, nothing else in the congruence has changed except for the day portion, and so H would also increase by 1 as we progress to the next day in the week. The second complicated looking part accounts for the month portion. Let's say we want to figure out which day is it for 1st May 2020. In this case, our Q will be 1, since it is the first day of May, and our M would be 5, so the month contribution would be 15. What is less clear though is how the formula works. Let me explain. If we list down the days of each month and take modulo 7, starting from March to December, then you see that they will follow a 3-2-3-2-3 pattern, which repeats every 5 months. What this means is, if we started off with 1st March as a Sunday, then since there are 31 days in March, which is 3 modulo 7, when we get to 1st April, the passage of a month would move us along the 7-day week by 3 days. So it will be Wednesday on 1st April. The clever part of this formula is that it observes that the 3-2-3-2-3 pattern repeats itself every 5 months. So moving from one month to the next, we move 3-2-3-2-3 days through the week cycle. Note that these numbers add up to 13. If we divide 13 by 5, we get 2.6. And adding 2.6 days per month before taking the floor function happens to achieve the intended effect, which adds the correct number of days we want as we move on from one month to the other. Now you can see the wisdom of letting February be the last month of our year in our calculations. By doing so, we need not account for what happens when we move from February to March in this part of the formula, because going from February to March will result in a year change, which the next part of the formula will handle. If we didn't let February be the last month, it will be quite hard and messy to come up with a formula to address the passage of months, because the days in February will no longer be fixed, depending on whether the year is a leap year or not. To see how the year change work, first note that there are 365 years in a non-leap year, which is equivalent to 1 modulo 7. That means the passage of a non-leap year moves us along the 7-day week cycle by just 1 day. So since 1st April 2021 is a Thursday, if you want to know what day is 1st April 2022, since every part of the formula is kept the same except for year, we see that H only increases by 1. So 1st April 2022 would be a Friday. It is also important to see how the formula is consistent internally. The total passage of days across 12 months or a full year in a non-leap year is 29, which corresponds to 1 modulo 7, as expected, similar to the passage of one full year. So far so good. But what is a floor function k divided by 4 for? It turns out that this accounts for 1 extra day in a leap year. Since a leap year typically happens every 4 years, this floor function would increase by 1 every 4 years to account for the extra day. It seems that we are almost done. Then what is this last part of the formula for? It turns out that our formula earlier has a flaw. Remember that the variable for year k is taken modulo 100. At the turn of every century, let's say, if we are moving from 1st July 1899 to 1st July 1900, we should technically only gain 1 day. Based on the rule above, this corresponds to the passage of 1 year. But since our k goes from 99 to 0 straight away, because we are working modulo 100 for a year, it no longer preserves the smooth change in h as we move to a new century. With the passage of a year, this portion should have given us an increment of 1 from 4 mod 7 to 5 mod 7, but instead, it now becomes 0 modulo 7, showing a gain of 3 days instead. This is how the minus 2j comes to our rescue. At the turn of the century, j got increased by 1. So the net effect of minus 2 bring 0 modulo 7 back in line to 5 modulo 7, which was what we had expected. And last but not least, remember that we mentioned a century leap year only happens every 400 years? That is what the last piece of the formula is for. As we go from 1999 to 2000, let's say, since 2000 is a leap year, we will gain a net plus 1 to our h. We spent a lot of time making adjustments to our formula so it works for the entire 400 years. But what happened beyond that? It turns out that our calendar year works on a 400-year cycle. The same days and dates will repeat and recur every 400 years, making the formula valid indefinitely. So that is the gist of how the formula comes about. I strive as much as possible to keep the explanation simple in order for this to be accessible to the widest range of audience. Now that you know about this handy formula, go on and surprise your friends and family by asking them what day is it on 31st January year 3030, let's say, and watch their surprise reaction when you work this thing out in front of them. What is even better is, next time you see someone using this formula, you will no longer think that it's magical. You know where it comes from and how it works. Okay, we have come to the end of this episode, and I look forward to seeing you in the next one. Until then.